Right. So let's start the discussion of special test paper 1. Right. So let's start from the first question. Right. In the first question, which of the following has dimensions of energy? Right. So guys, normally uh, there are some particular physical quantities they having a similar dimensions, right? So as example, now let's take this next one. Energy, work, right, and moment of force, moment of force. Or in some instances, we can able to consider this one as torque, right? So all of this having a same dimension. So the energy and the moment of force having same set of dimensions. So the answer should be the first fifth one for the first question, right? In the second one, which of the following quantities has no dimension? So guys, these are basics theories, right? So to definitely have this kind of knowledge, right? So the answer should be the relative density, isn't it? Relative density. So the answer should be the second one. Third one, following are some of the units used to measure the distance, right? Millimeter, micrometer, angstrom, light year, and kilometer. I think you should have idea about the millimeter, micrometer, and kilometer. The only things that you have less idea about the C and the D. So guys, keep in mind that angstrom is a special is a multiple units which is represent 10 to the power minus 10 meters, right? So this one angstrom is equal to this is the representation of angstrom is equal to 10 to the power minus 10, right? So light year mean it is also a kind of unit which is used to measure the distance, especially between the distance between planets, right? So light year mean the distance which is traveled by the light in 1 year. That is called the light years, right? So so this is the higher the largest unit, and the angstrom is the minimum unit. So the answer should be the uh, largest and the smallest unit. So the largest should be the light year, and the smallest one should be the angstrom. So the answer should be fourth one, right? In the fourth question, in this question given below, S denotes the distance traveled by the particle with an uniform acceleration A, initial velocity U in the time t. Right. So the answer should be, now let's consider the equation. Now it's x equal k half within bracket 1 plus at over 2u. Right. So now there are so many methods to simplify this question. So I am using I expand this equation, right? So it is equal to k half plus k half at over 2u. Right. So that's mean this equation consists of three terms. So if the equation is the accurate one, the dimensions and the units should be units of the each term should be equal each other, right? So then hence we can able to consider these two. The dimensions of x should be equal to dimensions of k half, right? So that's the theory. So then x equal k half. To obtain a value for k, I'm considering square of the both side. Then it is equal to, then k equal x squared. Now x represents the distance, so the answer should be the L squared. So the answer is second one. Right. In the fifth question, this is the given equation u1 equal 2m1 over m1 plus m2 squared into u2. Right. Now the question is, the equation is right. So guys, first of all, before obtain the answer for this question, I want to tell you some important things related with the addition and the subtractions of dimensions, right? So so this is the theory. Now let's take an example. Let's take this example. Now 2 centimeters plus 3 centimeters. So what is the answer? It should be 5 centimeters, right? So likewise, and let's take another one. 5 centimeters minus 4 centimeters. So what is the answer? It should be 1 centimeter. So likewise, if there's addition of units or subtraction of unit, the answer should be given one of these units, right? Because now 2 centimeters plus 3 centimeters mean answer is obviously is 5 centimeters. So likewise, in dimensions as well as the units, let's take this one. Meter plus meter. Then the answer should be definitely equal to m, right? So likewise, let's take the dimension. If we consider the dimensions, now let's take this one. L plus L. Guys, the answer should be the also L, right? So there's no two L. So keep in mind that. So that's why I tell you these examples. Let's take another one. This is the first example. This is the second one. LT minus 1 plus LT minus 1. So the answer also should be equal to LT minus 1. There's no any addition of the dimension. So this is also related to the units also, right? So keep in mind that. Then, now let's take another one. Guys, can we able to perform this simplification? Let's take this one. 2 centimeters plus 4 square centimeter. So generally, can we able to make this addition? No, because this in these two terms they are having a different types of units. So that's mean we can't able to obtain an answer by looking at this calculation. So that is it is the incorrect one. So likewise, if we are going to add or subtract a particular units or dimension, both or every unit should be in a single pattern, right? So let's take another example. Let's take L plus LT minus 1. So can we able to make at these dimensions? No, normally even there's a similar addition, similar dimensions, we put the dimensions of 1 as the answer. So however, we can't be able to add these dimensions because these are two different types of dimensions. So if there's a different types of dimension, we can't make any addition or subtractions, right? Then likewise, take this one. Can we able to make this addition? No, right? So this is also is an incorrect one. So that's therefore, if there's an addition, both units should be in same or the similar pattern, or the both dimensions or the dimensions of each term should be in same pattern, right? So let's take this example. Now guys, just concern about the denominator. So in the denominator, it is having m1 plus m2 square, right? So now the other thing is, now in this question, m1 and m2 represent the different types of masses, right? So let's as example, now normally we can be able to give this. So these 2 and 5 represent the different types of the two objects with having different masses, isn't it? So likewise, we use to express the two objects in algebraic version. We use m1 and m2. So these are normal representations of masses, right? So m1 and m2 are not the square. m1 and m2 represent there are two types of masses, right? So then now m1 and m2 mean masses, no? So that's why, therefore, if we substitute the dimensions, m1 mean it's a mass, so the dimension should be m, capital M. Then m2 mean it's also kind of a mass, so the dimension should be m, but we have to consider square, right? So if I substitute the dimensions, so we substitute the dimension in this instance, right? So now guys, you can able to figure out that the even there's an addition, the dimensions are different types. So that's mean we can't able to add this dimension. That's mean it is an incorrect one, right? So then, in order to make this equation in a correct way or the accurate way, we have to substitute. When we substitute the relevant dimensions, it should be in a same pattern, right? So therefore, to make this equation into a correct one, in this equation, it should be m1 plus m2, not the square, right? So if there's a m1 and m2, then we can able to make this simplification accurately, right? So the answer should be the fifth one, right? So the answer should be the fifth one. Okay. Right. In the sixth question, force P between two masses M1 and M2 separated by distance R can be written by having a proportional constant K with the dimensions ML minus 3 T2. Which of the following equation associated with the dimensions of K, right? So now we have to obtain the correct equation, right? So you know guys, dimensions of F should be equal to MLT minus 2. Dimensions of M1 equal to M, and also dimensions of M2 is also equal to capital M, and the dimensions of constant is given as M L minus 3 T2, right? So then now we have to obtain the correct equation, guys. The theory is, if the equation is an accurate one, then the each term, the dimensions of each term should be equal each other. That's a theory, right? So let's find out whether which answer satisfy this requirement. Let's take the first one. Now in the first one, it is mentioned that K M1 plus M2 over R squared. Now guys, P in this question, P represent the force. So then the dimension should be ML3 minus 2. Let's find out the dimensions in the right side. It is K. K mean ML minus 3 T2. Right. Inside, there's an addition of M1 and M2. So if I substitute the dimensions for M1 and M2, it should be capital M plus capital M over, now R represent the distance, so that's mean L squared. Now guys, you know that if there's addition of dimensions of unit, both these dimensions is in a similar way. So that's mean m plus m, instead of m plus m, we can able to consider a single m. That is, so keep in mind this simplification, right? Over L squared, right? So if I simplify this question, so if I simplify this expression, we can able to obtain that L5 T2. So this is the dimensions in the right side. So it is incorrect, isn't it? So this is expression is the incorrect one. So let's move on to the next one. So likewise, we have to obtain the dimensions in each term separately. So that's why the way we obtain the answer, right? So in this, according to the second answer, P equal to 1 over K m1 m2 over r squared. So guys, in the second answer, there's a multiplication between the m1 and m2, right? So let's substitute the dimension for the right side. Then instead of m1, it is m multiplied by m over k mean m l minus 3 t2 into l squared. So let's simplify this one. So then we can able to cancel these two. And if I simplify L minus 3 and 2, the answer is obtained as the L minus 1 in the denominator. When the L minus 1 and the t squared come to the denominator, it is converting, the sign of the index or index is changed, right? So that's why the answer should be, this is the answer, right? So that's mean we can able to obtain the dimension which is equal to the force in the right side too. So then we can able to consider the correct answer as the second one. So the answer should be the second, right? Okay, let's move on to the next question. Right. Value of coefficient of viscosity when measuring in SL units is X. Sorry, not it is not SL. It should be corrected as XI, right? SI unit is X, right? So now you should have an idea about the what is the units of coefficient of viscosity. Coefficient of viscosity. That is better to keep in mind these units, right? That is kg n minus 1 s minus 1. So this is the units of, or this is the SI units of coefficient of viscosity. And it should be equal to x, right? Then in a system where length is measured in centimeters, mass is gram, and time is second, right? So their required unit should be, instead of kilogram, they are willing to measure it from gram. Instead of meter, they should substitute centimeters, but we have considered the minus 1. Then x is remain same. So the value of the coefficient of viscosity is, right. Okay, now we have to convert now. Even the question is having a different type. Now in this question, you are asked to convert this unit into this one. That's the question, right? Okay, now you already know how to make this unit conversion, right? That's mean kg m minus 1 is minus 1 over gram. I used to make a bracket. Then let's make a simplification so we can able to cancel these two. Then in the denominator it is k and m minus 1 is cancelled. Then the denominator it is remained, that is c minus 1, right? So I think you might familiar with this kind of simplification, and you should have idea how should this minus 1 come to this instead come to with centi, right? Then k represent 10 to the power minus 3, sorry, 10 to the power 3, centimeter 10 to the power minus 2, even though we have to consider the minus 1. Right? So that's mean 10 to the power 3, and in the denominator It's having 10 to the power 2. So when it's come to the numerator, the answer should be the 10. Right? So in order to convert this unit, x should be, this is the numerical value, x should be multiplied by 10. Then we can be able to convert this unit change, right? So guys, answer should be the 10x, right? So the answer should be the fourth one. In the eighth question, in an experiment about friction, frictional force acting on a falling sphere with radius a and speed v is given by this equation, F equal KAV squared, right? We have to find the dimensions of K, right? So now, first of all, let's subject the K, then is equal to F over AV squared. Now, F mean MLT minus 2 over, here A represent the radius, that's mean L. V mean velocity, so it should be LT minus 1, but we have to consider the square. Then MLT minus 2 over L, right? So this can be cancelled, and also we can able to cancel T minus 2 in the numerator and as well as the denominator. So the answer should be ML minus 2. So the answer should be the second one. Right. So these questions are very simple one, right? There's no any difficult questions in this paper, but so these are the normal standard that you need to know, right? So you can evaluate yourself by doing these questions, right? So if there are any kind of issues, you can able to go through the notes or the theoretical points and gain the required theories to solve these questions. That's it, right? Okay. Now let's go on to the ninth question. Guys, in the ninth question, heat capacity of a solid C can be given relative to temperature in the following formula, right? That is C equal alpha T plus beta T cube, right? So here C represent heat capacity. C represent heat capacity, right? So now there's a I think you don't have any idea about the heat capacity. You might or not. However, there are two things to know about this related with this question, right? That is, guys, heat capacity and the specific heat capacity are two different types of physical quantities. So you should know it that point, right? Heat capacity and the specific heat capacities are two types of physical quantities. That's the first one. And I think you know the related equation for the specific heat capacity, right? Because you have learned in the O levels, right? That is Q equal mc theta. Now in this equation, you can able to figure out the units or the dimensions of C. Now in this question, in this equation, Q represent the heat energy, right? In this equation, Q represent heat energy, M mean mass, C mean, now in this equation, C represent the specific heat capacity. Specific heat capacity. And theta represent the temperature. Actually, it is temperature difference. However, we can able to consider it as a temperature. Right? So this is the equation related with specific heat capacity. Right. But on the other hand, if you have to know about the specific heat capacity, I will tell you the related equation for the heat capacity also. That is Q equal S theta. Now guys, in this equation, Q represent heat energy. Q represent heat energy and theta represent the temperature. And in this equation, S represent the heat capacity, not the specific. It is just the heat capacity, right? So by substituting the relevant units for this equation, you can able to obtain the units of heat capacity, right? So guys, now the question is asking about heat capacity now. So that's why we have to obtain the units for heat capacity, right? Okay. Now I think this equation might be a fresh thing for you, but even though to try to learn this equation from today onwards, right? So that's the purpose of doing these questions, right? So let's find out the units of heat capacity. That is, if it is Q equal S theta, then S equal Q over theta, right? So let's substitute the units. Now, guys, normally heat Q mean it's a heat energy. Even though it's heat energy, it's a kind of an energy, right? So if you want to if you want to obtain the units, you have to normally substitute the units in SI unit system, right? But even though in this question now, especially when you solving the questions in the solving MCQ questions, it's better to go through the answers before make the simplification, right? Because then by looking at the answers, you can able to gain some kind of related things, right? Okay, now here, if you go through the answers, you can able to figure out that there it is mentioned in the answers, they are mentioning about the J. J means a joule, right? So you guys know that joule is a unit which is used to measure the energy, right? So that's why we have to substitute the energy in joules, right? But no, most of the times we have to substitute the unit in SI unit system. But in this question, you have to substitute the joule as the unit of energy, right? So it should be joule. Now the unit of temperature is obviously Kelvin. But in some instances, they use Celsius as well. So if you go through the answers, you can able to figure out that they are substituting in temperature in Kelvin, not in the Celsius, right? So the unit should be JK minus 1. So this is the units of this is the unit of specific heat capacity. This is the unit of heat capacity. Right. So now let's go to the question. Now in this equation, it is consists of three terms, isn't it? So as you know that if the equation is an accurate one, that each term should having a same equal, right? So then let's take these two because we are asked to find the units of theta, right? So then C should be units of C should be equal to dTq, right? So then B equal to C over TQ. Then if I substitute the units, C mean heat capacity, so that's mean is JK minus 1. T mean temperature should be substituted as Kelvin. So the answer should be fifth one, right? Okay. Okay, guys. Now let's move on to the next question. Right. In the 10th question, there's an equation given that is P plus A B squared into B equal nRT. Now the question is asking about the dimensions of constant A. Now P is represent the pressure and B is represent the volume, and other terms also is defined, right? So guys, now in this equation, you can able to figure out there's a bracket, right? So inside this bracket, there are two terms. So then, if the equation is correct, then the dimensions of P should be equal to dimensions of A over V squared. That's the theory, right? If it is, if I subtract the A, then it is equal to PV squared, right? So let's substitute the dimensions. Now P mean ml minus 1 t minus 2. V mean, guys, it's volume, no? So the dimension should be L cube, but we have to consider the square of the volume. So that's why the answer should be this is the answer. The answer should be third one. Right. In the 11th question, consider the following statement. So these are very basic questions, right? Dimensions of pressure. So the A statement is correct. Dimensions of surface tension. It is also correct. Guys, I think you have you have familiar that with this equation, right? Surface tension can be obtained by using this equation, that is force over length. Right? So it's better to have an idea about this equation, because normally most of the instances you are asking about the surface tension, right? So that's why. So if I substitute the dimensions, we can able to figure out that this is the dimensions of surface tension, right? So the P statement is also correct. Relative density is a dimension less quantity, that is also correct. So the answer should be the fifth one. All the statements are correct. In the 12th equation, I made a mistake, right? Because I have done the 12th question, not the 11th one, right? So let's come to the 11th question. In the 11th question, equivalent to 1 kilowatt hour is, right? So this might be a little bit difficult for you, but even though it's better to have an idea, right? So now you are asking to find the value of kilowatt hours in joule, right? So guys, first of all, you have to know about those stuffs, right? That is what can be expressed as joule per second. So keep in mind these theoretical points. These are theoretical things, right? What is the special unit or special name which is used to measure power, right? And we will learn in future that there's another unit which is used to measure the power, that is joule per second, right? K is minus 1. So instead of what in this unit, I'm substituting 1 kilo. Instead of what, I'm substituting J is minus 1 into hours, right? Okay, then now guys, if I substitute the relevant values, now K means kilo, no? So kilo means there's a numerical value, that is 10 to the power 3. Instead of kilo, I'm substituting, because kilo is a prefixes, or there is a multiple unit which is represent this numerical value, right? Then I state the joule, the same one, same procedure, and it's minus 1. Then guys, the H represent the hours, right? So you know that 1 hour consists of 60 into 60 seconds. If I convert hours into second, that's the equation. 1 hour is equal to 3,600 seconds, right? How to obtain this one? Because 1 minute consists of 60 seconds and 1 hour consists of 60 minutes. So in order to convert this unit conversion, we have to multiply the 60 by 60, right? Then if I substitute this value into the expression, instead of hours, I'm substituting this one, right? So then we can able to cancel these two units. So at the end, we can able to figure out that, right? See, so the answer should be 3.6 into 10 to the power 6. The answer should be the fourth one, right? Guys, I know this is a little bit difficult one, but it's better to have an idea, at least a rough idea about this unit conversion, right? Okay, in the 13th question, the value of particular quantity can be written as x kg in minus 2 is minus 2. Assume that the above value can be written as y j c minus 2 is minus 2. Relationship between x and y. So guys, this is this question is also is asking about the unit conversion in a different way, right? Okay, now let's convert this unit. Let's convert this unit into this one. So what is the procedure? We have to consider this one and divide from the other unit. Right. So I always repeat that. Now here it is mentioning about the CM. So it's better to put a bracket to minimize to avoid the make some misunderstanding, right? So it should be x minus 2. Then if I simplify this one here, this kilo remaining is remaining in the denominator and m minus 2. So instead of this one, this can be written as c minus 2 m minus 2, isn't it? So we can able to cancel these two. Then kilo mean 10 to the power 3, centimeter 10 to the power minus 2, but it should be, we have to consider the minus 2. Then 10 to the power 3, and in the denominator it should be equal, it is 10 to the power 4. So if I simplify it, so that this is the answer. Then that's mean if I multiply x from 10 to the power minus 1, we can able to obtain the answer for y. Then x equal to y over 10 to the power minus 1. That's mean x can be written as x equal 10 as x equal 10y. So the answer should be the third one, right? In the 14th question, specific heat capacity. Oh, guys, now in this question, they are asking about the specific heat capacity, not the heat capacity, right? Specific heat capacity is given by the equation C equal A plus B T squared, right? So someone has asked about can a same symbol can be used for different physical quantities? So answer should be is the yes, right? So normally we use same symbols to represent different types of physical quantities, right? So then the next question is how should we identify whether what is the exact meaning of this symbol, right? So the answer should be most probably they are provided in the questions, right? Most of times, 100% they should provide it in the they should be provided in the questions. Otherwise, we can able to obtain the meaning by looking at just a symbol, right? So normally, if I tell you some example, normally we use M to represent mass, but in some instance there are various types of meaning for M, right? So it's better to go. So in the question, they should be defined what is the exact meaning of the given symbols, right? Okay. Now, this is the equation. The C represents the specific heat capacity. And at the end of the question, there's the equation to obtain the unit of specific heat capacity. Now, guys, you can able to use the previous equation, which is mentioned as Q equal MC theta to obtain the dimensions or unit of specific heat capacity. However, let's use this equation. Equal to equation, it is mentioned that C equal or specific heat equal to energy over mass into temperature. Right. So let's substitute the units for this equation. So guys, as I mentioned earlier, it's better to go through the answers before obtaining the unit, right? So if you concern the answers, you can able to figure out that they are providing J. So J represent joule, right? So that's means if there's a physical quantity of energy, you should substitute the unit as J, not in the SI unit, right? So the energy should be equal to joule, mass means kg, and temperature, right? So as I mentioned earlier, temperature can be substituted in Kelvin or in Celsius. So it's better to go through the question and the answers, right? In some instance, you are asked to substitute the SI unit for temperature. So that's mean you have to substitute Kelvin. But in this question, they are considering in the Celsius. So that's mean if there's a physical quantity called temperature, you have to substitute the units and in Celsius, right? So let's substitute this unit as Celsius. So this is the unit of specific heat capacity, right? Okay, now let's go for the question. Now we have to find the units of A and B. Now guys, straightly you can able to find the units of A, isn't it? Because if this equation is correct, then the unit of C should be equal to units of A. Then units of A equal to J, so joule per kilogram per Celsius, right? So let's move on to the other one. That is, we have to find the units of B, right? So I'm considering these two terms, right? So then units of C should be equal to units of BT square. Now, if I subject the B, then B equal to C over T square, isn't it? Right. Let's substitute the relevant units. Now, C represent J, K, G minus 1, C minus 1 over T represent Celsius, but we have to consider the T squared. So that's mean C squared. So if I further simplify this one, I can, so when it's come to the denominator, it is converted to minus 2. So then the answer should be, this is the answer for B, right? So the answer should be the first one, sorry, second one. Got it? Right. Let's move on to the 15th question. Real gases deviated PV equal nRT and their behavior can be expressed by the equation as P plus A N over B squared and B minus NB equal nRT. Now here P represent pressure, V represent volume, and N number of moles, and R mean the universal gas constant. T is absolute temperature. The question is units of A and B, right? So guys, let's consider this brackets now. Inside this bracket there are two terms, isn't it? So according to the theoretical things that we learned, units of P should be equal to units of An over V squared, right? This is the theory, right? So if I subject the A, then A equal PV squared over N. Now, if I substitute the units for P and the other relevant physical quantities, now guys, now you know what is the SI units of pressure, right? But even though if you go through the answers, you can able to figure out that it is substitute as a Pascal, isn't it? Right. So then we have to substitute the units for pressure as Pascal, right? Is Pascal into V mean volume. Now, guys, we have to consider the V squared. Now, you know that units of volume is m cube. Even though we have to consider the square over n mean more number of moles, so the unit should be in mole. Then the answer should be m6 per mole. So this is the units of A, right? If we consider this bracket to obtain the units of N, units of B, according to this equation, units of B should be equal to units of NB. Right. So if I subject the B, then it is equal to B over N. Now, if I let's substitute the relevant units. Now, B mean volume, it should be M cube over N mean number of moles. So the answer should be M3 per mole. Right. Right. So there's a mistake in the answer script. So let's consider this one as the odd, right? Okay. Now, however, you can able to know some relevant, some important things related with these units, right? By go through this question, and these are the way that we obtain the units in a given terms, right? Okay. Let's move to the next 16th question. In the 16, which of the following pairs contain quantities with same dimensions? So guys, I have told you that there are some physical quantities having same set of dimensions. What are the examples? So at the very beginning of this discussion, I told you that energy, work and moment of force or torque having a same set of units as well as the dimension. So please keep in mind that. So that is the one example. The other one is pressure and Young's modulus having a same dimensions and units. These are not the same physical quantities, even though their dimensions and units are equal. The other thing is momentum and impulse having same types of units and dimensions, right? So to obtain the answer easily, you should have an idea about these examples, right? So this example represents the physical quantities which having same dimensions and units. That's it, right? Okay. So the answer should be the fourth one. Answer is the fourth one because impulse and moment having a same set of dimensions, right? Let's move on to the other one. Kilowatt hour is a unit of, right? This is a common question. Kilowatt hour. This is the units of kilo. That's the unit which is represent the kilowatt hour. Guys, kilowatt hour represent an unit which is used to measure the energy. Right. So I have discussed this question in several times. Right. So in your sport exams. Right. So keep in mind that. So the answer should be the second one. In the 18th question, light year is equivalent to. All right. So I told you in this paper that light year is a unit which is used to measure the distance, right? If I further classify it, it is a unit which is used to measure a long distance, like distance between two planets likewise. So now question is asking about the we have to convert this light years. We have to now it's obviously it is a kind of a length, so the unit should be meters. But we have to provide the distance which is represented by a light year in kilometers, right? Okay. Now, guys, as I told you in the previous, right? Now, light, the value of a light given in the question, right? That is 3 into 10 to the power 8 m is minus 1. So what's that mean? That's mean, guys, light is moving this amount of distance within 1 second. And there's another thing that you need to notice, that the answers is given in kilometers, right? So if I convert this this value into kilometers, so we have to convert meters into kilometers. What is the procedure? Meters should be divided from kilometers, right? So that means 1 over k. You know that k represents kilo. That is 10 to the power 3. So when it's come to the denominator, so in order to convert meters into kilometers, you have to multiply the given value in 10 to the power minus 3, right? So that's mean if I provide this unit in kilometers, I have to multiply this given value from 10 to the power minus 3, right? That's it, right? So that's the meaning of this value. So that's mean now light year mean distance traveled in 1 year, within 1 year, right? Then on the other hand, you should know that 1 year consists of 365 days, right? So now I'm going to do is I'm converting this time duration into seconds, right? So 1 year consists of 365 days. 1 day is consisting of 24 hours. 1 day is consisting of 24 hours, right? So if I convert this value into hours, I have to multiply it from 224 24 to convert these days into hours, right? So in order to convert these hours into seconds, now you know that, guys, 1 hour consists of 60 into 60 seconds, isn't it? That means 360, 3600. So I have to multiply this value from 360 to convert this value into seconds. So that's mean this is the second. If I provide the 1 year in second, this is the answer, right? So then, if it is now according to this value, we have know that light is moving 3 into 10 to the power 5 kilometers within 1 second. So if it is, we have now 1 light year is consist of the distance traveled within this time seconds or time period. So that's mean 1 light year can be obtained by multiplying this 3 into 10 to the power 5 kilometers from this amount of time. This is the answer, right? Okay, now then the answer should be the first one. So these are a little bit difficult ones, but however, you have to be idea about those things, right? And if you are willing to obtain a high marks for physics, these are essential things. So these are not the not Some fantastic things, right? So these are just a normal thing. The only thing that you need to do is just adhere to these kind of theoretical things, right? Okay, let's move on to the next question. Which of the following is equivalent to the unit of power? Right. Now, first of all, you have to remember the equation which is related with power, that is energy over time. Or it can be given as work over time. So both this equation can be accepted, right? To obtain the units of power. Then, now we have to obtain the units given set of units, isn't it? Right. So now, guys, I'm taking this one. I'm using this equation, right? That means power equal to work, power equal work over time. Now you know that on the other hand, work is equal to force into distance, right? So if it is, power can be substituted as force into distance over time, right? So then substitute the relevant units for this physical quantities. Now, if you go through the units, you can able to identify that it is mentioned about the Newton. So, guys, Newton means it's a special unit or special name which is used to measure the force, right? So, instead of force, I am substituting Newton instead of SI unit, right? So, in D mean meters, time mean S. So, this is the unit of work, right? So the answer should be second one. Right. In the 20th question, there's the equation is given, that is 5 over 3 a squared minus b squared into h. Right. Where a, b and h are lengths, phi is numerical constant, quantity which is calculated by the above expressions, right? Okay, now guys, if I substitute the unit, I can able to neglect the 5 over 3. So A means a length, so it should be substituted as in cube. Minus B also is represented this length, so it should be also substituted as in cube. H should be substituted as min. Right. So instead of these two, there's a subtraction m squared from m squared. So the answer should be m squared. It should be multiplied by m. So that's mean answer should be m cube. Right. So guys, m cube is used to measure the volume. So the answer should be the fifth one. Right. The 21st question. Right. So there's another unit conversion. You have to convert this unit into kilometers per square minutes, right? Okay, now the normal procedure is m divided from km, right? So guys, this is related with times now. So I make this conversion. I make this rearrangement to obtain the answer easily, right? Right. So whatever. That's it. That's fine, right? Just keep this one in same as the in the first step, right? So now, guys, you should know that 1 minute consists of 60 seconds, right? So instead of minutes, I'm using 60 seconds, and it should be, we have to consider 10 to the power minus 2 into the power minus 2, right? Then, if I further simplify it, I can able to cancel these two. Then s minus 2 over kilometer 10 to the power 3 and this should be, if I simplify this bracket, this should be substitute as 60 into the power minus 2 and is minus 2, right? So then we can able to cancel these two, and if I take this 16 into the power minus 2 into the nominator, it is converted to positive, right? So let's make this further simplification. That's mean 3.6, right? So in order to convert this unit into this one, we have to multiply the given unit, given numerical value from 3.6. So the answer should be the 35.3. Then the answer is fourth one. Right, guys? Okay. In the next question, the volume of water passing any point of a uniform tube during t seconds is related to the cross-sectional area of the tube, velocity u of the water by the relation v proportionate to a alpha u beta t gamma. Which of the following is true? Right. So now this is let's do dimension analyzing, right? So so let's first of all let's substitute the dimensions. We represent L cube equal a mean time square, so that's mean L into the power 2, but we have to consider the alpha into the power alpha. U mean velocity, that's mean LP minus 1 into the power beta. T mean time, it should be substituted as T into the power T. So let's analyze the dimensions, each dimensions. So if I consider L, 3 equal to alpha plus beta. So let's consider this one as a first one. If I consider the T, then I can able to obtain that. Now in the left side, there's only L. So that's why we can able to consider it as 0. Minus B then we sorry, I have to consider beta plus and the gamma 2. That's mean beta equal, sorry. So this should be minus 1 beta, so minus beta plus gamma. So that's mean beta equal gamma, right? So in the question, they are not asking about the exact value. We just have to find out the just a simple relationship. So guys, according to this obtained values, we can able to figure out that beta is equal to gamma, right? But even though actually we can't able to obtain a value for alpha, that's why let's consider that beta is equal to gamma. That's correct, but it is not equal to alpha, right? So that's why we have to consider the answer as the second one, right? In the 23rd question, which of the following relations is dimensionally correct, where h is height to which a liquid density rho rises in a capillary tube of radius r. T is the surface tension of the liquid. Theta is the angle of contact. G is the acceleration due to gravity, right? So guys, however, you should have the idea about that. T mean by go through the question, you should have idea about that. You should identify that T represents the surface tension. Theta is the angle. R is the radius. Rho is density, and G is gravitational acceleration, right? So let's find out which equation is the correct one. So let's start with the first one. In the first equation, this is the given equation, isn't it? 2t cos theta over r rho g. Now guys, let's consider the dimensions. So if the equation is correct one, the dimensions of each term should be equal. Now in this equation, there are two terms. It is consist of two terms, that is h, and the other one is this one. So to be correct, to be accurate the equation, the units of both sides should be equal. Then you know that dimensions of h is a distance, or it's a height, so that means it's a distance, isn't it? So it should be L. Now let's obtain the dimensions of this term. Right. So guys, you know that when you consider the dimension, you can able to neglect the numerical values or the coefficients. Right. Then T represents the surface tension. So you know that this is the dimensions of surface tension. And guys, here they given the cos theta. Now you know that dimensions of trigonometric ratio is now the dimensions of there's no dimensions for the trigonometric ratio. So that means the dimensions of cos theta is a dimensionless. So that means it can be considered as 1. Right? So these are theory, right? So instead of cos theta, I can able to substitute it as 1. Now r mean radius, that is L. Rho mean density. So you know guys, this is the unit dimensions of density. L mean G mean gravitation acceleration. So it should be LT minus 2. If I further simplify this one, T minus is cancelled, M is cancelled, then 1 over L minus 1. So when it's come to the denominator, it is equal to L. Alright, so guys, that means both sides or the both terms having the same dimensions, right? So that means the first equation can be considered as the accurate one, right? Right. Let's move on to the 24th question. The frequency n of vibrations of uniform string of length L and stretched with a force F given by this equation, where P is the number of segments. So that means it is a dimensionless of vibrating string, and M is the constant of the string. What is the dimensions of M? Right. So this is the given equation. N equal P over 2L over F root F over M. Right. So now when considering the dimension, we can able to neglect the P, right? Then now we have to find the dimensions of M. So guys, first of all, I'm subject the M, right? So this is not the exact procedure that you need to follow, right? You should have your own unique procedure. That's up to you. But in this discussion, I'm normally prefer to use the most the longest or the extended method, right? So that's why everyone can able to understand. So that's why I'm using the extended version rather than doing the simple tricky points, right? Okay. So first of all, let's subject M. So that's why the M is inside the root. So that's why I'm considering square in the both sides. Then it should be substituted as n squared p squared over 4l squared. Then if I consider the square of a root sign, the root sign is excluded. Then if I subtract m equal to p squared f over 4l squared n squared, right? So you know that dimensions of frequency is equal to t minus 1, right? So when obtaining dimensions of m, you can able to neglect p squared and m4 because they are numerical values. So f mean t minus 1 over l mean it's a length. So it should be substituted as l squared. N mean sorry, sorry. Now F mean force, isn't it? So it should be substituted as this one. Now N mean T minus 1, but even though we have to consider a square, then NLT minus 2 over L squared T minus 2, then it is cancelled. Then the answer should be this is the dimensions of N, right? So answer should be the fourth part. Okay, in the 25th question, if the velocity for V, force F and energy E are taken as fundamental units, then dimensions of mass, right? So guys, this is something a new thing, or this is not the actual new thing, but this is a kind of question type that you can able to given at the exam, right? So normally we know that there are 7 fundamental units in our physics syllabus, right? Isn't it? But in this question, they are asked to assume that these are the fundamental units, right? This is just an assumption, right? So even though now you have to, now the only thing is you have to obtain the dimensions of mass in terms of F, V and E. That's it, right? Okay. Now let's consider the first answer. So guys, there are different types of method to obtain the answer. So I will tell you the easiest one, right? That is, you have to substitute the units or dimensions for this given equation. Now, in the first answer, it is given as FV minus 2E. Now, you know that V is volume. Now, let's substitute the dimensions according to the fundamental dimension that we learned, right? So, that means V mean L T minus 1, but we have to consider the minus 2 to the power minus 2, right? So E mean energy. That is the, now guys, what is the dimensions of energy? ML minus 1, T minus 2. So if I further simplify this one, now you know that dimensions of mass mean capital M. Now, however, we have to obtain the capital M when we after the simplification. That's it. Right. So now guys, this should be minus 2 and this one plus 2, isn't it? Now, because we have to multiply L from minus 2, that's mean minus L minus 2, L into the power minus 2. T should be multiplied minus 1 from minus 2, that's mean positive plus 2, isn't it? So this plus 2 is cancelled this one. So now guys, the units, the dimensions of energy. Dimensions of energy is equal to ml squared t minus 2, right? So this should be squared, isn't it? So these two also is cancelled, then answer should be the m. See, so by using this equation, we can able to derive the dimensions of mass. So this is the correct equation. That's why answer should be the first one. Right? Okay. Now in the 26th question, if the time period t of a drop of liquid density d, radius r and vibrating under surface tension S is given by the formula T equal dA RV and SC. We have to consider the root. If A is minus 1, and C is plus 1, then B. Now we have to find the value for B, right? So now first of all, guys, let's exclude this root sign. That is, we have to consider the square of the both side. Then it can be written as T squared DA RB is C. And they have given the value for A and C, right? So let's substitute the dimensions. T squared, D mean density, which should be ml minus 3. Now A can be considered as minus 1. R mean radius, so it should be substituted as LB. S means surface tension, so it should be substituted as M T minus 2 into the power plus 1. Right. So now, however, we have to find the value for B. Now let's consider the dimensions of L. Now let's analyze the dimensions of L. So in the left side, there's knowing dimensions of L. That means we have to consider the index as the 0. Minus 3, sorry, this should be plus 3, isn't it? Plus 3 plus B. Then B should be equal to minus 3, right? Right. So when you're obtaining the answer, you need you can consider about the minus value. So however, this is the correct answer, right? Okay. In the 27th question, in the measurement of a physical quantity x is given as a squared b over c into 1 over 3 d into the power 3. The percentage error introducing the measurement of the quantities A, B, C, and D are 2, 2, 4, and 5 respectively. Then the minimum amount of percentage of error in the measurement of X is contributed by, right? So when consider about the A, we have to consider the A square. So that's mean percentage error which is measuring A can be obtained by, this is the 2 is the percentage error of A, but it should be multiplied by 2, isn't it? Because the power is 2, so that's why answer is 4. This is the error, the percentage error of A, which is contributed to the X. Let's find out B percentage error of B. It should be equal to 2, isn't it? Let's find out the percentage error of C. Now we have to consider the into the power 1 over 3rd, isn't it? So then this is the percentage error, but it should be multiplied by 1 over 3. So this is the error which is caused by C, and D, it should be, we have to consider this is the dimension, this percentage of D, but we have to consider the 3. But that means it should be 50. So the least amount of contribution is C, isn't it? So the answer should be the 3rd one. Now guys, we have learned that in the fractional errors, in measuring X can be obtained by adding the fractional error which is caused by A, B, C, and D. So that's mean the fractional error when measuring X can be obtained by adding these 4 values each other, right? But in this question, they are asking about the which one having the minimum contribution or minimum error contribution to the X. So that's mean we have now, I am considering the percentage error of each physical quantity separately, right? So that's why the least or the minimum amount is obtained when measuring C, right? Because you know that, guys, if you given the percentage error of the particular physical quantity, it should be multiplied by the power which is represented in the equation. So that's why I'm multiplying this 2 from 2 when obtaining A. P having a 1, so that's mean it should be multiplied by 1. But in the C and D, we have to multiply by from 1/3 and the 3 in each instance respectively. Right? Okay. Now guys, in the 28th question, the error in measurement of radius of a sphere is r, right? So the percentage error in measuring radius is 1%. The error in measurement of volume is, right? So you know that guys, volume of a sphere can be obtained by using this equation, right? So in this equation, 4/3 is there's a numerical value and pi is also is a numerical value. That means R3, R into the power 3 contribute to the B. So that's mean if you want to find the percentage error of B, you have to multiply the percentage error of R from 3. So the percentage error of R is 1%. So the answer should be the 3%. Right? So these are just a normal things, right? Normal questions. But you have to be familiar. Then, in the 29th question, if the error in the measurement of the volume of a sphere is 6, right? So the now volume of a sphere can be obtained by using this equation, no? Right. So the percentage error of measuring volume is equal to 6. Then the error in measurement of its surface area, right? So you know that guys, surface area of a sphere can be obtained by using this equation. 4/5 r squared, right? So that's mean both in this equation they having r, right? Because 4/3/5 and 4/5 are just a numerical values. So there's no any contribution for the errors in measuring physical quantities from the numerical values. But even though, now let's assume that guys, percentage error of measuring radius, percentage error in measuring radius as x, right? So now you know that guys, the percentage error in measuring b can be obtained by multiplying percentage error of radius from 3. Isn't it? So in this question, they are providing the percentage error of measuring volume. So that's equal to 6. Then it should be equal to 2%. Then if it is, then we can able to find the percentage error in measuring area by using percentage error of radius is percentage error in measuring radius is 2%. It should be multiplied by 2. That the answer should be the 4%. Right, so the answer should be the third one. Right. Guys, there's a small error in the 30th question. So let's consider it as the or because there's a issue in the question. There's a issue in the question. That's why I considered the answer as the old one, right? Right. In the 31st question, the percentage errors in measurement of length of a simple pendulum and its time period are 2 and 3 respectively. The maximum error in value of the acceleration due to gravity obtained from this measurement is, right. So according to the equation, it is equal to 5 over LG, right? So now guys, you know that according to this equation, we can able to find, now let's assume that now they have given the percentage error of measuring L and T are 2% and 3%, right? So now now let's consider the percentage error of measuring G as X. Then we can able to obtain the T by considering this equation, isn't it? So in obtaining errors, we can able to neglect the 2, 5. That's a numerical value. So then percentage error of 3 can be obtained by, now L root L mean root LG mean L square. Now this equation can be considered as, can be rearranged as 2T 2, 5 L into the power half over G into the power half, right? So then now you know that it has a division, subtraction, addition or multiplication. Error is always is at each other. Then percentage of T is equal to 3. L mean 2, but it should be multiplied by half plus G, it should be also multiplied by 2. Sorry, it should be also multiplied by half, because here it is mentioning the power as the half, right? So this should be 1 plus x over 2. So 2 equal x over 2, then x equal to 4%. So this is the answer for the right. So there's an error in the answer. So that's why let's consider this one also as the all questions, right? So guys, if there's a error in the questions or in the answers, you are provided the whole marks, right? Okay. In the 32 question, the mass of the heaviest stone that can be moved by the water flowing in a river depends on the speed of water. Right. So mass is depend on the speed of the water. Let's consider this one as the P into the power of A. Density of water, D into the power of B. And acceleration due to gravity, that is G into the power of C. Right. So now we have to do is, we have to make the dimension analyze and have to obtain the value, or we have to obtain the, we have to derive the equation, right? So let's substitute the dimensions. Now if M means mass, so it should be capital M. Equal V mean velocity, so it should be substituted as power A. G mean it is density, so it should be substituted as ML3 minus ML minus 3 into the power B. D should be substituted as LT minus 2 into the power of C. Now let's analyze the dimensions. Let's starting from M. So M, it should be 1 equal to B. So then B is equal to 1, isn't it? Right. Let's go for L. Now in the left side there's no any L, so that's why let's consider it as 0. L equal 0 equal A minus 3B plus C. Right? But we already have obtained the value for B. So let's substitute it. The values is plus 1. Then A plus C should be equal to 3. Right? Let's move on to the L. Sorry, T. In the left side, it should be 0 and minus A minus C. Then A should be equal to minus 2C, isn't it? So if I substitute this obtained value For the third equation, we can able to consider that three equal instead of a, let's substitute it as minus 2c plus c. That means c 3 equal minus c. Then c should be equal to minus 3. Right? So then m proportionate to v into the power of, right. So then that's mean a should be equal to minus 3 into minus, sorry, minus 2 into minus 3 mean 6. b into the power of 6, b into the power of 1, and g into the power of minus 3. Then m is proportionate to b into the power of 6, so the answer should be the third one. In the 34th question, sorry, so guys, this is the 33rd question, right? In the 33rd question, amplitude of a damped oscillator of mass m varies with, according to this equation, A equal A naught exponential AT over m, right? So guys, now by looking at this equation, you should have to identify that this is the exponential, sorry, this is the exponential function. So according to the theoretical things, exponential function is a dimensionless. That means the dimension should be equal to 1. Then, if the m is the mass and t is the time, then if I subject a, then it should be m over t. So if I substitute the dimensions, m should be substituted as capital M over t, then the answer should be the mt minus 1. So the answer should be the first answer, right? Okay. In the 34th question, there's an equation b squared over ga over 2 phi plus 2 phi gamma over rho a. Now guys, they have defined the each term. Now the question is, we have to find the dimensions of a, right? So in this equation, it is consists of 3 terms, isn't it? So I am considering these two. Dimensions of b squared should be equal to dimensions of ga over 2 phi, right? So when obtaining the dimensions or units, we can able to neglect the numerical value. So the dimensions of a should be equal to dimensions of b squared over g, right? So b mean its velocity, that is L t minus 1 into the power 2 over g mean gravitational acceleration, so it should be Lt minus 2. So if I further simplify this one, so the answer can be obtained as L. So the dimensions of A should be equal to L. So the answer should be the first one. In the 35th question, right, so there's the equation is given as n equal n naught exponential minus lambda t, right? So now as we discussed in the earlier question, this is the exponential sign, right? So this is the exponential function. Now you know that exponential function is a dimensionless. Then it is equal to 1 over t. So if I substitute the dimensions, 1 or it should be 1 over t. So the answer should be the t minus 1. So it is in the t minus 1 can be given as m into the power 0 L into the power 0 and T into the power minus 1. So the answer should be the third one, right? Sorry, second one. In the 36th question, right, so first of all, I will list these things. In the 36th question, we have to find the dimensions of V. Now, this is the given equation, V equal K root F over M. Now, we have to find the dimensions of K, right? So, let's substitute the, now there's a root sign, isn't it? So, it's better to exclude this root sign. That's why I am considering the square of the both terms, right? So, then it is V squared equal to K squared over F over M. Then K squared equal to B squared M over M, right? So let's substitute the dimensions. Then B means velocity, isn't it? So it should be L T minus 1 to the power 2. M mean mass, so that should be in capital M over force mean MLT minus 2. Then this can be cancelled. L2 T minus 2 over L T minus 2. So this can also cancel, and then we can able to obtain that K squared equal to L. So that's mean guys, K equal to L root, sorry, K, the dimensions of K equal to root L. That's mean instead of root, I can able to substitute it as L half. So that's the answer. So the answer should be the fourth one. In the 37th question, which of the following is not a unit of energy? Right. So you can easily obtain the answer, that is kilowatt, guys. Watt or kilowatt? Watt or kilowatt are units of powers, right? So the answer should be the first one. In the 38th question, when sound waves of frequency F and amplitude A travel through a medium of density rho, the following statement can be correct for the energy contained in unit volume of medium, right? Guys, now there are some certain things that you need to know related to this question, that is amplitude. Amplitude means, so keep in mind that amplitude means it's a kind of a length, right? Amplitude means it's a kind of length. So the dimensions of amplitude is equal to L, right? On the other hand, the question is asked that E represent energy. E represent energy contained in unit volume. Now, how should we be able to obtain the dimension or equation for this E? E mean energy contained in unit volume. So that's mean E represent energy over volume, right? So this is the way that we derive the equation in this kind of instances, right? So I have told you these things, right? Okay. Now first of all, let's find out the dimensions of E. that is ml square t minus 2 over L cube. Then this is the dimensions of E, right? So P is density, F is and frequency, and A is amplitude. Let's consider the first equation. It is E equal P A F squared. So let's find out the dimensions of this term. Now P represent density, that is ml minus 3, A mean L. F mean now F frequency, you know that what is the unit of, what is the dimensions of frequency, that is t minus 1, we have to consider the square. Then L minus 2, t minus 2. So this is the unit of, this is the dimensions of this term, but it is not equal to the E. So, so then A is not the correct one. Now in the B question, we have to consider E equal P A squared F squared, right? So P mean in L minus 3, A mean L into the power 2, T mean T. Right. So then we can able to obtain the same dimensions, right? So this should be correct one. And in the C, because the only difference is now in this C expression, it is there's a including of K. Now K mean it's a dimensionless constant. So that's mean you can able to obtain the same answer as in the B. So the C statement is also correct. So the answer should be the B and C, that is fifth one. Right. In the 49th question, sorry, 39th question, the radiation energy emitted per unit time from a unit area of a rigid body at temperature T is given by E equal lambda T squared, equal lambda T squared. If K is the dimensions of T, then dimensions of lambda are, right? So now guys, keep in mind that now E represents energy emitted per unit time from unit area. Now, how to derive the equation for E in this as this format? So that's mean now I have always mentioned you that if there's a unit, there's a physical quantity starting with unit, that mean it should be included in the denominator. So then E should be equal to energy. Then we can able to derive the equation as energy. So time and the area should be written in the denominator, right? So that's why we develop the equation. So then dimensions of energy mean ml squared T minus 2 over T into L squared. Then it should be mt minus 3. Okay, let's substitute this one into the equation. That is mt minus 3 lambda. This should be substitute T into 4. So the lambda should be equal to m T minus 7. Right. So there's no any specific answer for this question too. But guys, then you can able to learn something which is looking at this question, isn't it? Uh, Guys, there's a huge error in this question, right? Not the question, in the simplification. Now here T represent the time, temperature, isn't it? So I misunderstand with this T, right? So it should be Nt minus 3 equal to lambda. If I subject the temperature, it should be K into the power 4 because the dimensions of temperature is given in the question, right? So then dimensions of lambda can be considered as in T minus 3 K in K minus 4. So this is the answer. So it should be, answer should be the second one. Right. In the final question in this paper, the force acting between two masses proportional to only M1 and M2 here. M1 and M2 are masses while R is the distance between those two masses. What is the dimensions of proportionality constant, right? So now this is the equation, F equal K M1 M2 over R squared. Now they are asking about the dimensions of K. Now what is the procedure? We have to subtract the K, that is FR squared over M1 M2. So let's substitute the relevant dimensions. Now F mean MLT minus 2. R mean is distance, so it should be L squared over M into M, that is M squared. So the dimensions of K should be M minus 1, L3, T minus 2. Answer should be the fourth one. Right? Okay. Answer should be the fourth one, right? Fourth one is the answer. Okay. Now guys, this is the end of the discussion. Special test paper 1, right? So I think so there are some 4 mistake in the questions. So otherwise, so I think you have learned something during this discussion. And if you have any kind of issues, just leave a comment in the comment section, right? So thank you. Have a great day.